quantitative literacy. These are the notes for 12.5 part B. We're looking at this normal curve, that bell curve again, and we're going to be looking at the z-score table that gives you the standard normal curve areas. This is posted in the Unit 3 materials as a PDF, and when you open it up, it looks like this, and it has 2 pages to it. I know it just looks like a giant series of numbers, but we'll explain, or I'll explain what the heck is going on here in just a little bit. But to give a little background here, when we're talking about the normal curve, I mentioned this in the last video, its entire area under the curve is equal to 1. So the area under the bell curve, that's a terrible bell curve, but the entire area under here is equal to 1, exactly 1. What we're going to do is find areas of slices of this curve. We had already talked about in the previous lesson using that empirical rule that if, for example, we are 1 standard deviation above, which, by the way, being 1 standard deviation above means that we have a z-score. Oops, that's supposed to say z. Let's try that again. We have a z-score of 1. We talked about how this is 34% of the total. As an area, then, that would just be 0.34. If I moved this and said, okay, now instead give me the z-score of 2, so 2 standard deviations, so now I'm 1, 2 standard deviations. That would be a z-score of 2, by the way. We talked about how that was the 34% and the 13.5% put together. Or as decimals, that would be 0.34 and 0.135, which would give me 0.475. So the area of all of this would be 0.475. The entire area, remember, is always 1. Now, here's the thing, and I hinted at this in the last video, a lot of data points will not land perfectly on one of those z-scores. Again, the mean's in the middle. Let's say that a z-score landed at 1.24, meaning it was about 1 1/4 standard deviation. So a full standard deviation, and then a little bit more, a quarter of another one. The question is, how much area is that little stretch? That's where we're going to use that sheet, the z-table sheet. So what the table tells me is the area from a positive z-score, and again, on our curve, positive z-scores are this way, negative z-scores are this way. It gives me the area between some positive z-score and the mean, or the middle of the curve. Now, here's the thing, it only tells me the positive ones, but since the curve has a symmetry to it, if I give you a negative z-score, let's say, for example, I went with, let's say I had a z-score of negative 1.4, for example. If I wanted to know the area from that mark, from that z-score to the middle, well, on my sheet, it's only giving me positive z-scores. I can go to the number positive 1.4, and this purple area would be exactly the same as the blue area. So basically negative z-scores, just realize that they would have the same areas as positives. So on this example problem, if I said, hey, what's this blue area? What is that area? I would actually go to the number positive 1.4 on my z table. If you notice, they have z-score area. So I would go to positive 1.4 for a z-score, which is down here. I don't know why this is highlighting a whole bunch of stuff, but right here. Oh, it's highlighting everything now. And the area that goes with 1.4, let's just get rid of all that mess. The area that goes with 1.40 is 0.419. So the area of this blue would be 0.419. And also, if I cared, the area of that purple would also be 0.419. Now, when I'm saying these areas, these relate directly to probabilities. When we get into word problems on this, these relate to probabilities, and then moving the decimal over twice makes them a percentage. So they're all the same concept. So again, basically, what this table tells me is the exact value of areas from some z-score back to the mean, back to the middle. It gives me the areas of these bands. So for number 1, find the percent of area under a normal curve between the mean and the given number of standard deviations. So again, those standard deviations are z-scores. So for 1A, negative 1.68, negatives are below. Negative 1.68 is somewhere here. It wants the area of this. So again, even though it gave me a negative, I'm going to go to the positive of that. So I'm going to go to positive 1.68. And positive 168 for z-score goes with 4.54. Sorry, 0.454. Sorry about that. So it would be 0.454. Now this is where you got to be careful. And on your homework, this will happen. Some of the problems say percent. Some of the problems say probability. Since this is saying percent, I have to move the decimal place over twice, and the answer would be 45.4%. That's a percentage sign at the end there. For letter B, 2.45. So 2.45, that's a positive number. That would be somewhere way over here. 2.45 is wanting this area, and then I'll turn that into a percentage after I figure it out. So on my table, z-scores, oh, it only goes to 1.79, so I've got to go to the next page. 2.45 goes with an area of 0.493. So the area of this purple is 0.493. So to make it a percentage, I just move the decimal place over twice, and I would have 49.3%. Now that's between some number and the mean, the middle. I can also give you between two separate z-scores. So let's see how we're going to attack this. You can see here I've added a permanent normal curve, so I don't have to keep drawing and erasing it. So a z-score of negative 3.02. So negative z-scores down here. And positive 1.47. So I don't know, somewhere around here. Now don't worry about how far over you draw these z-scores. I know a little bit more about where they are just because I've dealt with them. But as long as you have positives on the right, negatives on the left, you're good. Now, what it's actually asking me for is this entire area. But remember, my chart only tells me things to the middle, to the mean. So I'm going to basically do this problem in two pieces. I'm going to find the area from negative 3.02 to the mean. If I look at my table, 3.02 goes with an area of 0.499. .47 to the middle, that purple area. Okay, so I've got to go to my table and go to 1.47. It's going to be on the other page. 1.47 goes with 0.429. The red and the purple together are going to give me the entire area. So I'm just going to add these together. If you add those together, you would get 0.928. Again, this problem is asking for a percentage. So I'm going to move the decimal place over twice. Oops, still got my highlighter there. And that's going to be 92.8%. So most of the curve's area is between those numbers. 92.8%, almost all of it. Now, letter B is a little funkier. On letter B, both of these z-scores are on the right. So 1.31, let's say that's somewhere around here. And 1.73. So here's the logic on this one. Since I have to be kind of clever here, since my curve only gives me, or my table, I'm sorry, only gives me areas to the center, here's going to be my logic. I'm going to find this blue area. So I'm going to look at the 1.73 z-score. 1.73 goes with 0.458. So the blue area is 0.458. But I don't want all of this red area included in that. I only want the area between the red and the blue. So I'm going to subtract off the red area. So if I go to 1.31, that has an area of 0.405. And again, I'm going to subtract those and basically think of it as a picture as I'm subtracting off all of this stuff. As I subtract that off, that will leave me with just the bit that I want. So if I subtract that, I get 0.053. If I move the decimal place over twice as a percentage, then it's 5.3% of the area. Now the next two problems switch it up. Now they're giving me a percentage of the area, and now it wants the z-score. So now I'm going to be doing everything backwards. So what do I mean? Okay, looking at 3A. 20% of the total area is left of z. Well, let's think about this. I'm trying to figure out, First, where does this z-score lie? Is it over here to the left? Is it over here to the right? Well, I know if it was right in the middle, that would mean that 50% of the area is left of it, because half of it's over here. But if it's saying only 20% is left of it, it must be a score over here. So there must be some score where to the left of it is 20% of the area. I'm going to turn that into a decimal. So if I move the decimal place over twice, 20% turns into 0.2. So 0.2 is this. Now, again, my goal is to figure out what the heck this z-score is that has that. Well, remember, my table only tells me from z-scores to the middle. So we've got to think about this. I need to know what would this be as a decimal. Well, I know this is half, so this is 0.5 here. That means this must be 0.3. So I am looking for 0.3 on my areas on the sheet. So I'm looking for under the areas now. I'm looking on the areas. See, they go Z area, Z area. I'm looking for the number 0.3. Unfortunately, the areas slowly increase, and 0.3 goes with a z-score of 0.84. So the z-score is 0.84, but be careful, 0.84 is a positive number, so it's to the right. So that must mean that the z-score I wanted was negative 0.84. You can see that it is very important to draw a curve pretty much every problem to figure out what it is that you're given and what you're looking for. On letter B, 79.4% of the total area is left of Z. So again, I've got a z-score. I'm trying to figure out where that z-score lies. Where along here is that z-score? Well, again, if it's in the middle, 50% is to the left. It's more than 50%, it's 79.4, so it's gotta be somewhere over here. So it's gonna have to be a positive z-score this time. So there's some mark where from that mark all the way over to the left is 79.4%. Or as a decimal, 0.794. Again, though, my z-score table only gives me areas to the middle, not all the way across. Well, we know that over here is half. So I'm going to figure out what this chunk is. And the way I'll do that is I'll take the whole thing, 0.794 minus 0.5. That'll give me 0.294. That's the area that I'm looking for. So I go back to my table and I look for 0.294 in the areas. And fortunately, that was very close to the previous one. Here's 0.294 for an area. That goes with a z-score of 0.82. So the z-score is 0.82. And this time, I'm not going to change it to negative because it is on the right side. So the z-score is positive 0.82. All right, that's where we'll stop this first video, and we'll get into word problems on the next one.